Hello, so today we'll be looking at how we prepare for the citric acid cycle. And by that I mean, how do we convert pyruvate, which we gain from glycolysis, into acetyl-CoA, which we need in order to proceed into the citric acid cycle. So here we have in front of us the overall reaction. As we proceed from pyruvate to acetyl-CoA, there are three important key steps, which includes decarboxylation, which we form CO2, and an intermediate that then gets oxidized, meaning we lose electrons, and then the resulting intermediate can bind with coenzyme A in order to form our final product, acetyl-CoA. So, there are a few important enzymes in order for this overall reaction to occur. One of them being the pyruvate dehydrogenase complex. As illustrated here, there's three subunits in this complex, E1, E2, and E3. And we also need a few other coenzymes in order for this to occur. This would be TPP, lipoic acid, FAD, NAD+, and coenzyme A. So, to start off with, step 1, decarboxylation of pyruvate. So this occurs in the E1 portion of the pyruvate dehydrogenase complex, and it starts off with pyruvate, obviously, but also with TPP, and this is the carbanion form of TPP. So to start things off, let's assume that this is a double bond and this is a single bond. So the lone pair on this oxygen forms a double bond that then breaks apart this single bond so that these break apart. This results in the CO2 formation, but we also get a carbanion, right? The lone pair, and so what happens is that this lone pair can then grab onto a proton such that we form an aldehyde. Okay, now the TPP, the carbanion form, performs a nucleophilic attack on this carbon. As a result, this double bond shifts onto the oxygen, and this oxygen will then grab a hydrogen, so that as a result we get this newly formed product or intermediate, the hydroxyethyl TPP, which we can now proceed into the second step, which would be the oxidation of this new intermediate. So this now again takes place in E1 of the complex, and so what we don't see have happened here is prior we did have that oxygen on carbon, and what happens is the lone pair on sulfur will grab that hydrogen, turn this into a carbanion, so that as a result the sulfur has the hydrogen. This is positively charged, and then we get this ionized form of the hydroxyethyl TPP. So from here, the lone pair on the oxygen forms a double bond, and then as a result, this lone pair, the bond breaks here and we form an anion. Because of this, we get this reforming the carbanion of TPP, which we need in step 1. So that's pretty cool. It gets recycled. But going back to this portion, the lone pair on the carbanion carbon will attack that sulfur. And so this bond breaks and we get the electrons neutralizing that sulfur, and this combines with that. So as a result, we get this acetyl lipoamide. So that's oxidation. And in the next step, we have step 3, formation of acetyl-CoA. this takes place now in E2 of the complex. And what we have is that previous product, the intermediate acetyl lipoamide, reacting with coenzyme A. So the lone pair on this sulfur will perform a nucleophilic attack on that carbon. As a result, this bond breaks, and such that this lone pair on sulfur can grab that hydrogen. So what we're forming here is ultimately our product that we want, which is acetyl CoA, and then this new product, dihydrolipoamide. So steps 1 through 3, we see that we ultimately form the product that we need for citric acid cycle, which is acetyl CoA. But we need to consider that we need to create this, we need to try and go into this pathway as many times as possible in order to ultimately go through the citric acid cycle. So as we saw reformed the TPP, we need to recycle this back into the lipoamide. So we proceed into a new step 4, which takes place in the E3 complex, E3 subunit of the complex, so that FAD coenzyme can grab these protons so that we get lipoamide reformed. As a result, we have FADH2 as well, which can then be oxidized by NAD+, by pulling a hydrogen, and then a proton is released. Ultimately, we get FAD reformed as well. We have NADH product and proton. So overall, we saw the formation of the acetyl CoA from pyruvate, as well as some of those important coenzymes being recycled back so that we can continue performing that overall reaction.